Hello, everyone. Good morning, good afternoon, good evening, depending upon where in the world you are. Welcome to the Next Geo and welcome to Geoawesome's 15th anniversary. As you can guess from the background that Alex has, we are celebrating our 15th year of existence and awesomeness. And we could have not been more happy to kick this day off with a series of presentations on maps, navigation, and search. And we have Cherie Wong with us, Senior Vice President from Mapbox, who's going to be talking about a topic that I find personally very, very fascinating and interesting, maps. And Alex will say a few words about his experiences as let's say, a cartography lover. Maps have been long looked upon as works of art, and that is changing a lot, right? Today, maps are digital infrastructure. If it doesn't work, you will notice it. So we're really happy to have Cherie with us today to share her vision of where we are headed and to answer any questions that you might have. So feel free to put down your LinkedIn profiles and contact information in the chat so that you can network with the other members of the audience as well. Alex, do you want to say a few words?
Well, I think you've stated it very nicely, Mutu. But indeed, maps evolved to be one of the critical infrastructures, right? Without it, we won't have other services that we all use, electricity, water, roads networks, rail networks, any infrastructure that we use in our daily lives. It won't work. It won't operate. So it's really interesting and exciting to see that sort of change over the past decade or so. So without further ado, let Cherie present, but please use the chats and ask questions. We'll make sure that your questions will be answered by Cherie and Mapbox team at the end of the presentation. So stay focused and have fun.
Well, thank you both. I'm super excited to be here, and I couldn't agree more with everything that you're all saying about how important maps are and how they exist as a global infrastructure for us. So just to start, picture this. It's 6:47 p.m. on a Tuesday. Someone just ordered dinner. A driver accepts the job, pulls out of a parking lot, and their phone, without them thinking about it, already knows the fastest route. It's accounted for a road closure that happened an hour ago, and it will silently reroute them if traffic backs up 3 blocks ahead. It knows which lane to be in before the turn, and when they arrive, it doesn't drop the delivery person off at a vague point on the street. It guides them to the exact entrance of the building. At that same moment, somewhere across the UK, a field engineer from Octopus Energy is on their way to install a smart meter, one of tens of thousands of installations happening that day. Their routing system already knows the fastest path, has adjusted for live traffic, and will reallocate their schedule in real time if a job runs long. They're not figuring out where to go next. The system has already decided. Neither of these people thought about maps today. They didn't have to. The maps just worked. And that's the most important sentence I'll say today. The maps just worked. Because behind that invisibility is an enormous amount of infrastructure. Data ingested from hundreds of millions of miles driven every day, systems that update in real time, pipelines that process over 1.5 million changes daily, all so no one has to think about it. For decades, maps were something you looked at. But today, maps are something everything depends on. And that shift from product to infrastructure is what I want to talk about. So what do I actually mean when I say infrastructure? Infrastructure has a specific meaning. It's the underlying system that other systems depend on to function. It's not optional. It's not a feature. It has measurable reliability requirements, defined interfaces, and consequences when it fails. By that definition, geospatial infrastructure means 3 concrete things. First, the data is continuously maintained and fresh. It's not versioned quarterly, it's updated daily, sometimes minutely, at scale, from multiple independent sources, with automated conflict resolution and human validation when necessary. Location data that is stale is not infrastructure. It can be a liability. Second, geospatial infrastructure is programmable and modular. Infrastructure is not a product you consume, it's a capability that you build on. And that means APIs and SDKs that developers can consume into entirely new products. It means a modular architecture that lets you configure exactly what your use case needs, and a builder-first mindset that treats the developer experience as a core product requirement. Third, geospatial infrastructure is built for the constraints of the real world. And that means high performance across device types, from a high-end automotive system to a low-end mobile phone in a market with intermittent connectivity. It means working online on a surface road and offline in a tunnel or on a mountain. And it means designing for the actual conditions your users are in. Those three pillars, fresh and reliable data, programmable and modular architecture, and real-world performance, are what enable us to make maps your global infrastructure. And they are what every decision we make at Mapbox is built around. Let me show you what it actually takes to deliver on them. To understand how we deliver on these pillars, it helps to understand where we started and how far that bar has moved. When Mapbox was founded, digital maps functioned like images. Every label, every color, every road baked into a rasterized tile on a server. If you want to change anything, you had to re-render it server-side and download it again. The maps were beautiful, but they were frozen. We changed that. Mapbox pioneered the vector tile format, moving map rendering from server to client, decoupling data from design. Developers could change any property, any layer on the fly, a genuine breakthrough at the time. But the world didn't stand still. Logistics networks started depending on ETAs accurate to the minute. Automotive systems needed lane-level precision at highway speeds. AI agents started making operational decisions that requires spatial grounding. The bar didn't just move, it moved to an entirely different category of problems. And that meant our model had to change too. Our first pillar, fresh and reliable data. We update the map with over 1.5 million changes every day. We credit many of these changes to the OpenStreetMap community, but OSM is just one input among many. We build our own data layers by running vast amounts of raw sensor data through our ML and AI processing engine. A single vehicle driving 3 city blocks captures hundreds of data points, and we have data from 2.1 billion miles of driving every week. GPS traces, front-facing cameras, satellite imagery, and user feedback all flow into the system, producing traffic conditions, crosswalk locations, lane geometry, speed limits, and more. Every vehicle in our network is simultaneously a consumer of our map and a contributor to it. Keeping that data fresh is harder than it sounds. Traditional map making sends survey vehicles out on a schedule. Capture, publish, wait. That worked when maps were visual products, but it doesn't quite work anymore. With HD lane level maps, a single construction project that adds a turn lane makes the map wrong in a way that matters immediately. The map gets updated 10 times faster than a traditional map would. To make it even more interesting, human drivers drive like humans, which isn't always the way the rules of the road are supposed to work. And we've all done it. We observe U-turns where they're supposed to be prohibited. We've observed drivers going the wrong direction on narrow streets in the middle of the night. We see drivers speeding with the flow of traffic at night, such that when drivers are actually following the speed limit, we're not sure if that should be considered congestion or clear road still. So the system has to be smarter than the behavior it's observing rather than naively trusting data. We run global change detection models that compare trillions of sensor observations against our HD baseline every day, flagging anomalies and updating the map automatically. The second pillar is programmable and modular architecture. What this means in practice is that developers can build exactly the experience their end users need using the same underlying infrastructure. A startup building a simple store locator. A company managing millions of on-demand delivery drivers across dozens of cities. An automaker shipping navigation systems in millions of vehicles worldwide. They're all building on the same platform, composing the capabilities that they need: real-time traffic, turn by turn, navigation, geofencing that triggers actions when a vehicle enters or exits a defined area, isochrones that show what's reachable within a given time, precise arrival points down to the actual building entrance. The infrastructure supports all of it. What each builder creates on top is entirely their own. Toyota is a good example of what it looks like to leverage that kind of modularity and customization. For the 2026 RAV4, America's best-selling compact SUV, Toyota brought navigation development in-house, building on Mapbox's rendering engine to create a map experience that enhances each vehicle's digital cockpit design. Dynamic lighting, textures, shadows, full-screen maps displayed directly behind the steering wheel. They used Mapbox Studio to style every detail to their own design language. And because Mapbox SDKs support over-the-air updates, Toyota can ship navigation improvements directly to vehicles already on the road. It's a platform that gave one of the world's largest automakers the creative control and technical agility of a software company. And that same studio capability is what makes Mapbox Standard, our flagship base map, so powerful for builders at every level. Every major map feature is customizable. Your fonts, labels, boundaries, roads, POIs, buildings, land use areas, all of it. Individual building facades now render with architectural depth. Windows, roof shapes, ground floor detailing, making these urban areas recognizable rather than abstract. And critically, every improvement we push to standard is delivered automatically. No manual migration, no update cycle. A developer building on Mapbox Standard today will have a better map next month without touching a line of code. The third pillar, real-world performance. Infrastructure has to work in the conditions your users are actually in, not just ideal ones. And that means a navigation experience that performs both on high-end automotive dashboards and on low-end Android devices in markets with intermittent connectivity. It means full offline functionality. For example, All Trails guides hikers through the wilderness with no signal, full trail maps and GPS navigation working entirely on device. Cars need to navigate long routes where there is no cell reception. Performance and reliability are constraints we must build into our designs from the start. The demands on all three of these pillars is only going to accelerate. And that is exactly why the AI thread we touched on earlier is not optional. That's what we'll come back to at the end of this talk, but first let me show you what all of this makes possible for the companies building on top of it. Earlier, I told you about a delivery driver and a field engineer. Neither of them thought about the maps. The maps just worked. But what does that actually mean for all the businesses that are depending on that kind of invisibility? That delivery driver, they were probably working for DoorDash. Mapbox powers DoorDash's estimated arrival times, optimized delivery routes, and driver-facing maps and navigation, deployed at scale across millions of deliveries every day. And here's a detail that drives a lot of our product thinking. Our analysis of delivery feedback found that 70% of failed deliveries near a destination happen in the final 10 meters. It's not the route, it's not the traffic, it's that last few steps to the door. And that's why we help bring drivers within meters of the correct building entrance across more than 100 million addresses in the United States. Infrastructure isn't just about getting people close, it's about getting them there. Octopus Energy's Kraken platform has built one of the most ambitious field operations in the energy industry, coordinating over 3,500 engineers across the UK every single day, installing smart meters, servicing EV chargers, maintaining the infrastructure that keeps homes and businesses powered. As that operation grew in scale and complexity, they needed location infrastructure that could grow with it. Mapbox powers the routing, real-time reallocation, and scheduling that keeps their fleet moving efficiently. And the result? 300 fewer hours of driving every day, 150,000 additional service appointments every year. A great operation that got measurably better. TripAdvisor has spent decades building one of the world's most trusted travel platforms, helping hundreds of millions of people discover places, plan trips, and build and make bookings with confidence. As they looked at how to deepen the engagement with their users and make the map a more integral part of that experience, they rebuilt it on Mapbox. They customized it to surface exactly the details that matter to a traveler in a way that felt native to the product rather than bolted on. And that depth of detail matters. Mapbox Standard now includes over 6,500 landmark icons across 450 global cities, so that a traveler looking at a map of Tokyo or Cape Town or Vatican City sees the landmarks that makes places feel real and not just a grid of streets. Since launching, user engagement is up 70%, and bookings are up 3.5%. A trusted platform became even more indispensable. Omnia Fishing has cultivated a deeply loyal community of anglers who depend on specialized map data that no general-purpose map provides. Water bodies, fishing spots, conditions, local knowledge. They rebuilt their mobile app on Mapbox, layering their proprietary data onto infrastructure that could handle it at scale and deliver it reliably, even in remote areas. Daily active users grew 221% after launch. That's a niche product that was already loved and that became one that people couldn't even put down. StubHub has long been the place that fans go to find the right seat for the right moment. Their interactive venue maps, one of the most important parts of the purchase experience, has served them well. But as their business scaled, the underlying infrastructure needed to scale with it. They rebuilt seat selection using the Mapbox tiling service, replacing a system that had done its job well with one that was built for the next decade of growth. The customer experience got sharper, and the engineering team got some time back. BMW has been building on Mapbox for 5 years, and in that time, the partnership has produced something more interesting than a standard vendor relationship. BMW designs and develops their navigation system entirely in-house using Mapbox Navigation SDK and Mapbox Studio to create custom map styles tuned to each vehicle model and trim. The result is navigation that feels unmistakably BMW, not generic in-car software. One of the more recent innovations is Curve Ahead View. Using the electronic horizon feature, the system pre-computes the driver's most probable path and loads roads features, speed limits, traffic incidents, road geometry, before the driver reaches them. That map isn't reacting to the road, it's anticipating it. And that's now in production across BMW and Mini vehicles, including the My BMW and Mini app used by over 7.8 million drivers. And Mapbox for EV is embedded in new BMW and Mini electric models, integrating with the battery system to forecast range and suggest charging spots based on real-time availability. Denokotsu runs the dispatch software behind approximately 23,000 taxis across all 47 prefectures in Japan. Their dispatchers and drivers operate in a high-pressure environment, confirming pickup locations, navigating congestion, managing multiple ride requests, all through a tablet that they need to read quickly and safely. But the challenge goes deeper than navigation. When a passenger calls and says, "I'm near the gas station," that phrase means nothing without spatial grounding. Which gas station? What's actually around them? Where should the driver go? Denokotsu needed a platform that could surface the right contextual information, POIs, the landmarks, precise pickup points. By moving to Mapbox, they gave their dispatchers and drivers the location intelligence to interpret the real world and not just display it. And then there's OpenAI, which has been augmenting the map experience inside ChatGPT search. It's not a map you navigate, but one that emerges from a conversation. Customized Mapbox maps responding to what a user is asking, presenting a location in the context of a natural language interaction. It's an early signal of where this is going. So we have static maps, map images on a receipt, a data visualization in a news story, a store locator, a fleet of thousands of field engineers, an in-vehicle navigation system, a conversational AI interface. These are all the same infrastructure, configured differently for what each builder needs. And that's what it means to be a global infrastructure. Not one thing for everyone, but a foundation that makes everyone's thing possible. I want to close with where this is all heading, because the shift we've described today is not the end of the story. It's the beginning of the next one. For the last 15 years, location infrastructure has been about making maps reliable enough that systems could depend on them. That problem is not fully solved. We work on it every day. But the frontier has moved. And the next frontier is spatial intelligence. Not just maps that systems depend on, but maps that systems can reason with. Today, AI agents are being asked to answer questions that are fundamentally spatial. Where should we route this delivery? Which field engineer is closest and available? What's the best location for the next door? What's reachable from here in 20 minutes? These are not search queries, they're reasoning problems. And they require location infrastructure that AI can actually work with. Structured, accurate, programmable, and current. And that's why we've built an expanding set of tools for the AI era, designed for two different kinds of builders. For teams building AI agents and applications, we have the MCP server, giving agents direct access to Mapbox location capabilities as tools that they can call, combine, and reason over. Within months of launch, it was natively integrated with Cloud Desktop, VS Code, GitHub Copilot, and recognized by the developer community as one of the leading geospatial tools in the MCP ecosystem. The DevKit MCP server goes further, with pre-built components and workflows designed to accelerate building location-aware AI applications. And we also have agent skills, which are reusable, composable building blocks that teams can drop into agentic workflows without starting from scratch. For teams that want powerful maps without writing code, Mapbox Studio continues to provide low, no-code environment to build, style, publish custom map and experiences. And that makes location infrastructure accessible to designers and to product teams, not just engineers. Across all of it, the goal is the same. Whatever you're building, however your team works, Mapbox should be the easiest way to make it spatially aware. At the same time, AI is changing how people interact with maps. We have OpenAI exploring maps that emerge from conversations rather than that navigation intent. We have Perplexity surfacing location, context, and site answers. The interface is shifting. It's shifting from a map that you opened to a map that appears when it's needed and shaped by what you asked. Both of these directions, AI as a consumer of location infrastructure and AI as a new interface for it, point to the same conclusion. The reliability and accuracy of the underlying data matters more, not less, as AI takes on more of the reasoning. A model that hallucinates a route or misplaces a business doesn't just return a bad result, it makes a bad decision. And that's why infrastructure grade is not a feature. It is the prerequisite for everything built on top of it, including what AI will build next. In a few hours, our location AI team will show you exactly what that looks like in practice, but the foundation they're building on is everything that we talked about today. I started today with two people who never thought about maps, delivery driver, field engineer. The maps just worked, and because they did, dinner arrived, a home got a smart meter, and somewhere a grid got a little more efficient. That invisibility is the hallmark of infrastructure done right. Roads don't ask you to think about asphalt. Power grids don't ask you to think about voltage. And increasingly, location infrastructure doesn't ask you to think about maps. It just works underneath the systems that move people, goods, energy, and information around the world. What's remarkable about this moment is the scale of what's being built on top of it. Industries that have existed for decades are being rebuilt around real-time spatial intelligence. Autonomous systems are learning to navigate a world that changes by the minute, and AI agents are developing the ability to reason about places the way humans do, naturally, contextually, without friction. The geospatial industry has always been about helping people understand the world. What's changed is the depth of that understanding, the speed at which it updates, and the breadth of systems that now depend on it. We're not just making maps anymore. We are operating infrastructure that the modern world runs on. And the most important chapter of that story is still being written. Thank you.
Thank you, Cherie, for that really interesting presentation. There are a couple of questions in the chat, and I also do have a question. In the last 5 years, regardless of what event we've hosted, Alex has always had the chance to ask the first question. And I'm not going to change that tradition today on our 15th anniversary either. So, Alex, why don't you kick things off?
Thank you, Mutu. This was really inspiring presentation, so thank you for that. One of the things that you've highlighted was that a lot of maps are already done to support AI. I'm wondering what the future you are foreseeing. Will we see more maps being generated by AI for other AI agents, or so kind of machine to machine, then machine to human, or human to machine? So do you see this already as a significant portion of the work that Mapbox does, and how do you see it evolving in the course of the next years to come?
Yeah, I think it's still, it's always been there, but it's also still somewhat nascent. So, for example, you're still kind of asking the map a whole lot of questions around where to go. Like those kinds of things have always existed. And then I see more and more the more complicated type of queries where you're thinking about multimodal transportation or trip planning or other things, or just even things where you're trying to look at a map and understand something like, what is the terrain? What's my cell coverage in this area? There's all these things that are kind of more geospatially aware. And I think the precision at which we can answer a whole lot of those questions is starting to change and get better. And oftentimes, especially when you're talking to all these enterprises, a lot of their customer service are kind of AI agents that are reading it right now. And so you do kind of have to have a lot more of that integration with humans as well as AI agents. And sometimes, to your point, it's going to be a human getting the answer. It's also going to be an AI agent getting the answer. And so the more we're also trying to embed the data and kind of the prediction of what is coming next is also in our thought process right now. But I would say that's still somewhat in development, depending on exactly how people use it. And so we're still in this process of observing exactly how people are using the maps and what they're asking.
All right, thanks. Before we take the two questions from the chat, when we say infrastructure, and I really liked your example of how we don't think about the power lines, how do we basically, assume it and take it for granted. And we're kind of increasingly moving towards that era for maps, if not that we're already there. On the other side, when we think about infrastructure, we don't think about innovation. It's one of those static, never changing areas of society, so to speak. How do you balance these two at Mapbox? Given on one side, you need to keep innovating, on the other side, you have a lot of companies relying on your data, so you can't just break things and say, well, happens.
Oh, I think you're asking the question we ask almost every day around reliability and availability and upholding everything that we think about how to be trustworthy, like the privacy aspects of things. Those are still top of our mind. But we recognize people want to see a little bit of wow when they're looking at the map. And that's kind of why I was talking about standard, because there's things like that I didn't quite, as a map user, even recognize that I really, really enjoyed. Like once I started seeing our cities in HD with the architectural facades, and it made it really difficult to go back to just looking at blank boxes on a map, even though they were in 3D. And so there's always this mix of making sure that we have that stability and that reliability, but like we ourselves also get really excited when we can innovate on something that's a little bit more of a wow. And so we're constantly trying to balance it. To your point, I don't know if we'll ever have the right the right proportion, but we are always going for both.
I'm glad you brought up 3D and cities at scale. There was a question in the Q&A section on whether you're using Gaussian splatting, the latest development when it comes to 3D visualization. This has been something that NVIDIA, Cesium, and others have been working on. Is this something that Mapbox is working on? How do you think about Mapbox? Was kind of one of the earliest companies to move into gaming and reality engines. So where are you with the latest developments?
I think I missed the question. Was it what kind of engine are we using, or how are we doing it with ML?
Exactly. So how is let me bring it up on stage. So is Mapbox using Gaussian splatting? What are your latest developments when it comes to infrastructure monitoring?
Yeah, I mean, from our standpoint, there's a bunch of different sources, and we mostly use machine learning algorithms, but I don't remember exactly which one. So if there's some interest, I can probably just follow up with the individual offline.
This is good because that's why we have the Mapbox booth and your engineers. So thanks for queuing that up. So for those of you who have more technical questions that we can't handle during this session for the lack of time, Andrew and the team from Mapbox is available at the virtual booth. So you can, head over to them, have a chat. I'm sure they will be very happy to talk to you. All right. We are at the half an hour mark, but I do want to ask you one final question before we wrap up the session. Keynotes like this, they give an insight not only into where the sector is headed, but also helps us understand where we started. And given that Mapbox has been one of the forefront in terms of map development, where do you see Mapbox in 2030? Do you still believe that AI agents are going to be doing majority of the, let's say, data quality work? Are we going to be in an era where we don't really know what's going to happen, even where we are today?
Oh, I think technology is advancing so quickly that it gets very exciting. Because like right now, if you think about it, we're in the search space in maps and in navigation. A lot of it is kind of still focused on human drivers and human movement, and a lot of that will start to change. And so if we start thinking also about where things are going from an autonomous point of view, from on-demand logistics as well as just driving, that starts to change a whole lot of things. And we're still trying to make sure that everyone, human and machine, on the road or in some cases on water, in the air, wherever they're trying to go, that they have the right underlying, to your point, infrastructure and data. And then we're grabbing all of that data and we're trying to figure out exactly where they need to go next. So if we were taking like human behavior and then trying to ensure that autonomous actually accounts for it and is able to kind of build on top of that, there's so many directions that this can go. And so I would say in 5 years, it's going to be a pretty healthy mix of complexity between the two. I think there will be a whole lot more AI agents. I think there's going to be a whole lot more just machines on the road. And then I think, again, the infrastructure is going to have to pivot a bit to adjust for both while still, growing and expanding. So I don't know if that fully answers your question, because I think it's more just that know yet, but I can see it changing really quickly.
It certainly helps to understand how you look at your product roadmap, right? And I guess for a lot of people, when they look at AI, they look at it as an incremental improvement to what we are currently doing. And that's also what my question was based on. But the fact that now we have to create maps for machines, and that's an aspect we've been working on for the last couple of years as a sector, but not at the scale where we are headed, not at the way that we've been thinking about it. So that's definitely quite interesting. And thanks, Cherie. Thanks a lot for your insights.
Thank you both.
All right, we're going to take a quick break. We will have the next session in roughly 25 minutes. So hope to see all of you there. Thank you.